Hello, I'm Adam Lawson, and today I'd like to talk to you briefly about the microbiology side of wine production. Sanitize your equipment. I can't stress this enough. This is the best way to avoid cross-contamination with other bacteria or molds, and we'll get into that a little bit later. Sanitizers may include halogens like iodine, ozone, hot water, peroxides, or sulfur dioxide. When I was doing my winemaking experiment, I used a combination of hydrogen peroxide for the fermenter bucket and then flushed it out twice with boiling water. All the other instruments were boiled. Now what you're seeing here is kind of a tour of the equipment I used. We've got our fermenter bucket. It's food grade. That way it's definitely not porous on the inside, so bacteria can't hide in it. It's very important. We have a large pot for boiling water and grape juice, in this case, or grapes. We have other instruments there. What's commonly referred to as a bubbler. It actually releases carbon dioxide gas very, very slowly. And on the far left is a mesh strainer. And I'll get into that here in a minute. Now, since I'm using grapes that I actually picked, juiced, and canned last year, there's a tremendous amount of pulp, and I'm using the mesh strainer to kind of get rid of some of the pulp, spoilage microorganisms. I'm going to focus mainly on the acetic acid bacteria. Basically, this bacteria results in the oxidation of ethanol, or your alcohol, into acetic acid. I should have in big, bold caps of vinegar, because if you ever got wine and it's turned and it's got a vinegar taste, that's what this bacteria has done to it. This gram-negative bacteria can create problems during post-fermentation, problems with taste, the smell, the clarity of the wine. You want to be able to see through it, and its stability. Now let's talk about other microorganisms that's commonly found on grapes that could end up in your wine. Molds. I've listed 3 of the most common. We know them as black mold, gray mold, and your blue-green mold. Your blue-green mold is actually what they make penicillin from. The main reason you worry about molds ending up in your wine is mycotoxins, such as ochratoxin A, which is a heavy-duty carcinogen. Potulin. It causes gastrointestinal problems and skin rashes. Now, I do have listed other things that is common to find on grapes, such as bacillus, colostrum, and streptomyces. But the truth is that wine is kind of a hostile environment, and we'll get into that a little bit later, and it's very unlikely that they'll live through the alcohol fermentation process. Now, what you're looking at here is me boiling the grape juice. And the grape juice didn't have a real sweet taste to me, so I went ahead and added some sugar. That way I can achieve the gravity when the yeast does its work. Now what you're seeing here is after the grape juice boiled, I added it to the fermenting bucket. The reason I boiled it is actually to keep certain bacteria, like we had already talked about, out of the wine. That way I wouldn't run the risk of spoilage. Now let's talk about the rock star of the whole winemaking process, the yeast. Yeast is the most important microorganism to winemaking. Yeast actually reproduce through ascospores. They appear smooth and elliptical. When you place yeast on a media, what you end up with is colonies that appear smooth, flat, sometimes they're raised and oblique. And I have 2 images here. One of Saccharomyces bayanus, which is commonly used in wine, and Saccharomyces cerevisiae, which is actually the one that's most commonly known as brewing yeast. These are probably the most common that winemakers use. Now let's talk about yeast metabolism and alcohol fermentation. Saccharomyces, or yeast, is converted. It basically converts grape sugars to alcohol and carbon dioxide. 1 mole of sugar yields 2 moles of each ethanol, or the alcohol, or carbon dioxide. And the process looks a little bit like this schematic. This is a very simplified schematic. Glucose basically makes 2 ATPs through a process that needs 2 ADPs and 2 phosphates to create 2 pyruvate. If you look to the side, I actually have the Lewis structure of pyruvate. And what happens when pyruvate becomes acetaldehyde is that it loses its carboxyl group off the end. And if you look very closely on that very far right end, you'll see an oxygen double bonded to a carbon that's single bonded to another oxygen. Well, guess what? That's your CO2 right there. And that's at that point between those two steps is where the yeast actually releases a CO2 or carbon dioxide. And then the acetaldehyde becomes the ethanol or the alcohol. I'm not going to talk too much about this, but malolactic fermentation is something that happens after alcohol fermentation. It's actually the conversion of malic acid to lactic acid. It doesn't happen as frequently as you would expect, because once again, wine is a hostile environment, like I talked about earlier. Wine has high sulfur dioxide. It has low temperatures. It has no nutrients because the yeast has eaten it all, and it has very low pH. But winemakers use these gram-positive bacteria to actually lower the acidity of the wine. And right here is just a brief look at some of those lactic acid bacteria, Lactobacillus, Pediococcus, Oniococcus. And with that, I'm going to say that's the end of my brief overview of the microbiology side of wine production. Thank you.